Next we have part B, which is the real aircraft has a square logo on its wings. The logo measures 130 centimetres by 130 centimetres. Harley wants to paint a scaled copy of the logo on his model. What dimension should Harley use for the logo on his model? Give your answer in millimetres. Well, if we've got 130 centimetres in real life, we need to do the opposite of what we did for A. We need to divide by 250. And if we do that, we get 130 divided by 250, which is 0.52 centimetres. So because we started with centimetres, we're still in centimetres. Now, to go from centimetres to millimetres, we need to multiply that by 10. And if we do that, we're going to get an equivalent measurement of 5.2 millimetres on the scale model. And because it's square, we're going to just finish it off by saying it like that. Next, question 17 is talking about blood alcohol content. Now, there's a lot of information here. I'm not going to read it all. Instead, let's move down to A and just see what the question's asking. It says, calculate Jeff's blood alcohol content at 11:30 p.m. Correct to 3 decimal places. Well, what do we need to know about Jeff? We need to know the number of drinks that he drank. We need to know how many hours he was drinking for. And we need to know his mass. Now, he's 78 kilos, so I'm going to put that in first. So I'm reading that up here. 78 kilos. He's drinking from 7:30 to 11:30, so that's 7, 8, 9, 10, 11. That's 4 hours, so we can put 4 in there for the number of hours. The number of drinks, though, he drinks 3, and I have to get my highlighter out for this. Drinks 3 large glasses of full-strength beer, so he's had 3 of those, and 1 small glass of mid-strength beer. Okay, so he's had 3 of those and 1 of those. So if we take that, and we have to do a little bit of working out there. So the number of drinks he had was 3 lots of 1.6 plus 0.8. And I'm just going to use the calculator for that one. We get 5.6 standard drinks, so that goes straight into the formula. Now I've got all the information, I can type it in. I've got 10 times 5.6 minus 7.5 times 4 on 6.8 times 78. We get 0.049, 01, so on. So to 3 decimal places, that is the blood alcohol content. Now, part B says that no, we're assuming he has a blood alcohol content of 0.6. How long will it take to get to 0? This is a straight plug into the formula. So time, I'm going to use a T for that, is 0.06 over 0.015. If I quickly do that, 0.06 divided by 0.015 in the calculator, I get 4 hours. That's the answer. Next, we've got this biscuit jar, or biscuit tin, I should say. Lots of information here. Once again, I'm not going to read it all now. We need to calculate the area of the label. Okay. Now, the area of the label, fortunately, is already shaded for us. So we're looking at this part here. Okay. Looking at that label. So we need to find that area. So, the surface area of a cylinder is pi r squared plus 2 pi r h. Okay, but if we consider what's happening there, we don't have the top or the bottom. So I actually don't want this at all. Because the moment we see pi r squared, we're looking at the area on top of a cylinder, okay? We're looking at this space. But in this case, we only care about the side of this cylinder. So I'm only going to use this aspect of the formula. So let's consider what we've got. We've got 2 times pi. That's not going to change. What's the radius? The radius, well, the diameter is 9. So we have to halve that. So the radius is going to be 4.5. So I'm going to put 4.5 in there. The height then is also 4. That's given straight. So if I put that all into the calculator, I get 113.097, so on. To the nearest square meter, it's 113, square centimetre, it's 113 centimetres squared. Next for 19, we need to put these, using this equation, we need to complete the table of values. Now it's important when you're using the table of values that you include brackets where you want the x. Okay, so for -3, I'm going to put -3 in brackets there. If you don't, you'll get different answers, and we don't want that because then we'll have a different picture. So that's -5. If I put in with -2, I get 0. If I put in with -1, I get 3. 0, I should get 4. Yep, 4. Put in 1, I get 3. If I put 2, I get 0, and you'll notice it's symmetrical there. Now I need to sketch that on the number plane. Now it's handy because I've already done all the work with the table of values here. So when it's -3, I have -5. So that's my first point. -2 is 0, -1 is 3, and 0 is 4. And then I do the same on the right-hand side. And I connect up those dots. But I have to make sure there's a bit of a curve there because this is a non-linear line. So include the curve, and that is the picture. That's the graph sketched on the number plane. It's also a good habit, I'll just do it now, to label your graph as well if you want to look really fancy. Next, pasta boxes are labelled, and with a net weight of 375 grams. And there's some more information there. The key aspects, though, is we're looking at the mean, standard deviation, normal distribution. So we're looking at the normal distribution topic. It says, what's the probability that a box selected at random will contain less than 375 grams of pasta? So, first of all, I'm going to draw up a pretty bad drawing of the normal distribution. In fact, I need a little bit of space. I'm going to make it just a bit smaller. So it says the business selling the pasta boxes fills them to a net weight of 380 grams. So the mean weight is 380. So I'm going to put that there, 380, with a standard deviation of 2.5. So that means every time I go to the right by 1 standard deviation, I'm going up by 2.5, and any time I go to the left, I'm going down by 2.5. So if I've got my 380 to start and I take away 2.5, I get 377.5. If I take away another 2.5, I get 375. Okay. For the moment, I'm only going to include that because I don't want to spend too much time populating a graph where I've already got the key bits of information. It says, what's the probability the box selected at random will contain less than that? So we're looking at this space. Probably should pick a different colour than yellow. It's a bit hard to see. Okay. What's less than 375? Well, let's first consider that this is 50% of that space. So that's straightforward enough. Then you can consult the reference sheet, or you can possibly just remember that the space here between the second standard deviations is 95, but we're only looking at half of that space on this side. So if I get 95 and divide it by 2, that's 47.5 in that space. But we don't want the space that we've got, that we've calculated. We want the space that we haven't. So we can take away those percentages from 1. So if I get my 100% and I take away my 50 and I take away the 47.5, I'm going to be left with 2.5%. Another way to think about it is ignore this side completely and just think, well, this is meant to be 50%. So if I take away the 47.5, you'll still get the same answer. Now, part B says the business sets a target of less than 16% of all boxes will contain more than 385 grams of pasta. The business can change the mean weight of the boxes to meet this target. What is the mean weight required to meet the target if the standard deviation remains at 2.5? Well, let's draw another standard deviation normal distribution curve. Oh, I think maybe we could get a better curve than that. Okay, that'll do. Now, at the moment, we've got a standard deviation. We'll stick with 1 for the moment. Okay. Now, we want less than 16% of all boxes will contain more than 385 grams of pasta. Okay, so let's consider how we can get 16%. So we've got here in this first zone, standard deviation between -1 and 1, that's 68%. Okay, so that entire space, which leaves, if I'm just caring about just this space, that actually will be half of that. Half of 68 is 34. 34%. Which means, if you consider the fact that this entire space from 0 to and onwards is 50% of the data, if we take off that 34, we are left with 16. So that means that this space in the red is 16%. Okay, so in order for us to get that new space of 16%, we need to get our, we need to make a shift, right? Because what's the shift, what's this currently? This is 382.5. We need that to be 385. Okay, so effectively everything's going to move up by 1. So this now, if you see it with the red up here, we've now got a new graph here where 382.5 is there, and now at this new space here, that's now 385, which then will work with the 16%. Now that's a lot of working out in images, but basically what we're saying is that at the z-score of 1, only 16%, 16% will be greater. Okay, right? So there's only 16% that's better than this. So that's why we need to make it now 382.5 as the mean, because the standard deviation hasn't changed. So we're basically just shifting everything up by 2.5. Next, the number of Year 12 students who completed 30 minutes of exercise for each of the past 10 days was as follows. It says, by first finding the median interquartile range, determine if 28 is an outlier. So, first of all, there's 2 ways to do this. I prefer to type it straight into the calculator because you'll notice that this order is not in ascending order, which means I have to rewrite it. And if I'm going to rewrite it, I may as well type it in the calculator to get all my answers. But it's hard for you to see, so I may as well rewrite it. I'm going to cross them off as I write them to make sure that I don't write anything twice. Oops, almost forgot 19. And then 28. Okay, so I've got all my data written there. Now we have 10 numbers here. So if I cut my data in half, which is there, that's where my median is. Now my median's the number between 15 and 15, so my median is just 15. My median's 15. Now to get my Q1, it's going to be the number in the middle of the first half, so that's my Q1. And same for the top half, that's my Q3. So the interquartile range is going to be 7 take away 13, which is 4. Now to determine an outlier, we need the formula which is on the reference sheet. Now it's just the upper, we're looking at the upper, so it's Q3 plus 1.5 times the interquartile range. So that's going to be 17 plus 1.5 times 4. And whatever that number that is, let's check. That's 1.5 times 4 is 23. Now any number bigger than 23 is an outlier. As 28 is bigger than 23, 28 is an outlier. Great, moving on. 22 asks us to construct a parallel box and whisker plot of the above data. Now I'm going to use the given number line here to give me a bit of a sense. And the lowest number I can see is 22.5. So I'm going to start at 22 and I'll move up by ones. Okay. Now 22.5 is the lowest number for the first class, and then we go up to 23.5, so that's not very far of a movement. Next, our median is 26.5. And then we have our Q3, which is 28. And then the max is 28.5, so that's where I'll put that. So that's class A. We've constructed one of the box and whisker plots. Now we do the other. 24.5 is the minimum. 25 is the next, which is the Q1. Then 26.5 is the median. 27 is the Q3. And 28 is the max. Okay. Now, the only thing I'll say is that to critique my drawing, those lines should be in line with each other. I'm going to blame the fact I didn't use a ruler, so I'm going to redo them just to make sure that they match what it's supposed to look like. So you'll see that these are in line because they're the same number, and these are in line because they're the same number. The others, none of the numbers are the same, so they're not as important. Next, now there's a lot of reading here, but basically I see a key word here, and that is z-scores. So I'm going to use the z-score formula to see which one is better. So we'll first do, I should have labelled before I move on. This is class B. Attention to detail there. So we'll do book phonetics first. I'm going to do B for book phonetics and G for great reads. So the z-score for book phonetics is going to be now given a rating of 78 on book phonetics. So 78 minus the mean, which is 60, over 12. And then before I pick up a calculator, I'm going to do it for great reads as well. So it got 84 on great reads, minus 76, which is the mean, over 8, which is the standard deviation. And then I'll type them into the calculator. And once I've done that, I get 1.5 for book phonetics, and I get 1 for great reads. So book phonetics is better. Next, we have the scatter plot here, and the scatter plot will be used to find the Pearson and the least squares regression line. Now, I can't really go into too much detail here because it's just all on the calculator. So, what's important is you need to go into stat mode, go to the bivariate data, which is if you press 2 once you get the options, but it looks like this. Okay, that is the option that we want. Then we get a table with X and Y, and you fill in all the information. So for instance, this first point here, that's got it. Now we normally consider this X, even though it says I, that's the X side. So we would do that first, so that's going to be 91. And then the Y value for that point is 78. And then we do it for the next one, 92. Oh, sorry, that was 79. So it's 79, and then we go 20, not having a day. Then we go 92 and 78. For good measure, 94 and 80, and then we do the rest. And then we finish off with 109 and 90. When you type all that in, you go to Shift 1, and then you click on Reg, and then you want R, and R will give you 0.982, so on, okay? And then for the least squares regression line, we do the same thing, Shift 1, Reg, and when we do that, we can get our A value, which is 22.176 to 3 decimal places, and B value, we can do the same thing, and we get this value, and then we need to put it in an equation. So normally we'll do y is equal to, but because it's in this form here, so you'll see y value is actually m, and the x value is actually I. We would write it as m is equal to, now the b value goes with the I, so it's going to be 0.615 I plus 22.176. Next, we've got a networks question. Now, I'm not going to go into detail again with all the information, but let's look at part A. Draw a minimum spanning tree for the network diagram below. So, a minimum spanning tree, what we're looking at is just connecting all the vertices in the minimum length possible. So these, I can see there's one, so I'm going to include that one first. Now what connects to G, H in the shortest way, and it's H, so I'm going to include that one there. Oh, sorry, F to H is 3, so that's the next shortest. Then I look at what's the next shortest. We've got a 4, 6, 8, and a 6. Well, 4 is the next shortest, so I'm going to include that one. Once again, which is the next shortest? We've got a 10, a 3. Now we don't need this one because they're both connected. So we've got a 10, a 3, or a 6 really. So the 3 is definitely the next shortest, so I'm going to include that one. Now how can we connect to C in the shortest way? We can either do 10 or 4. Well, 4 is definitely the shortest there. And then how can we connect to the dam in the shortest way? Is it the 6 or the 5? It's going to be the 5. Now, we can check that we've got a minimum spanning tree, or at least a spanning tree, if we count the number of vertices. We've got 1, 2, 3, 4, 5, 6, 7, and we should have one less line. We've got 1, 2, 3, 4, 5, 6. So 6 lines, 7 vertices. We're looking good. Now notice it says draw a minimum spanning tree. We don't need to add it up, but if we did, that one should be 20 kilometers. How do I know it's kilometers? Well, you'll see here it says the lengths of the pipes are in kilometers, which is important for part B. It says what is the cost in per meter. So we need to change the 20 kilometers to meters, and the way we do that is we multiply by 1,000. So 20 times 1,000, we get 20,000 meters. So if we take the 20,000 meters and we multiply it by $135 per meter, we've got a cost of, it's pretty big, 2,700,000. Wow, okay, it's a lot. So you'll see there, it's worth 2, but that's one of the marks is probably attributed to that conversion. Next and final question, we've got a table for future value of annuities. Now the future value, first of all, we need to look at, it's 5% per annum for 2 years, compounded annually. Great, so we just want 2 years for 5%, that's this value here. We just have to multiply the 24,000 by that 2.05, and if you want you can include the 2 zeros, but that doesn't actually make a difference. And if we do that, 3 zeros times 2.05, we get $49,200, and that's how much has been contributed per year. Okay, and if they do that, we end up getting 224,000 is how much we're contributing per year, and if we do that at the end of the 2 years, we have $49,200 at the end. Next for B, if you'll see here, it's 4% per annum. Oops, we need a highlighter there. 4% per annum, 6 monthly for 2 years. So that means if it's 6 monthly, we need to halve the percentage and multiply the time. So if we do that, I'll do a different highlighter here. Instead of 4%, we're looking at 2%. And instead of 2 years, we're looking at 4 years. So that's our value that we're using. So we take that 31,800, we multiply it by that number there, 4.1216. And if we do that, we get $131,066.88. Finally, we have C. Obviously, it's going to be a bit hard, it's worth 2, but Sophia aims to have a deposit for an apartment of at least $92,000 in 4 years' time in an annuity with an interest rate of 6% per annum compounded annually. So what we're going to do, once again, I'll pick a different highlighting colour. We want 4 years, 6% per annum, so we're looking here. So we're looking at that number, 4.3746. But instead of just multiplying it, we don't know what we're multiplying by. We're multiplying something by 4.3746. And when we do that, we get $92,000 because that's how much money she wants in the future. So to get our x, we just need to divide both sides. We need to divide both sides by 4.3746. When we do that, x is going to be 21,030, $21,030. And that brings us to the end of the paper. So hopefully these videos have helped, and we'll see you next time. Thanks.